Okay, good morning, everybody. So this week we have a special schedule. Today is the lecture, and on a Friday, the first hour will be recitation in this room, and then we will split. Group A will go to the labs, Group B will stay in this room for problem solving, and there is no in-lab session this week. So your homework lab will weight 80% instead of 75, just because we don't have the in-lab session. And lab one was due yesterday, and homework two, because of the holiday, is due Friday instead of Wednesday, which is the standard day. So, Cedric, do you want to tell? Yeah, and also in the end of class.
So if you remember me, I'm Cedric, I'm your SI, hopefully you remember my face and my name, you're gonna see it a lot often, right? Twice a week, maybe, hopefully. But yeah, sessions are finally finalized. My two sessions are gonna be Monday and Thursday, right? I didn't have the Monday session this week because Labor Day, I don't wanna work. But hopefully you didn't wanna work either. You relax and everything, hopefully. I have one tomorrow though. It's gonna be Thursday at 6:30 p.m. It's gonna be at Monroe 2000. If you don't know where that is, if you know where Artesanos is, it's gonna be. You're coming in from the SAU, right? You go see Artesanos. To your right, there's like a little door, and there's stairs going upwards. It's gonna be in that little area over there. You'll find it. I'm gonna be outside. I'm gonna like wave people and everything at 6:30 tomorrow, right? And then Monday session, also 6:30 p.m. It's gonna be CSD 2101. I don't know what the numbers is on top of my head. I should have sent an email out.
Yes.
That's gonna be where Commons is, second floor. I don't know where the room is exactly. I'm gonna try and figure it out at some point. But when I do, I'm gonna send another email out. But yeah, I'll announce it one more time at the end of class, just so you guys remember that my session is tomorrow. You guys should pull up. Other than that,
Yes. Okay. So today we will talk about Python data types, input and output streams, conditional expressions, scopes of the functions, and the fruitful functions. And if time allows, I will talk also about the scopes of the files, the modules. So, I I don't feel this. Um, uh, um, uh, so you're familiar with some functions, with turtles, for example. You can call some methods of this file, of these modules, of these functions, and pass some parameters to these methods. If you write forward, you write just digits, but without quotes. If you pass the color name, you're using quotes. So now we will talk about the differences. Moreover, you can create variable. So if you, well, blue is a short word, but for example, if you have a long sentence here and you want to reuse it several times, you could create a variable, which means to store this string in your computer memory, and then uh, call this string using this name. This name is called identifier. So everything like functions, your files names, variables, when we create them, we create identifier. And identifier in Python has two rules. The first rule is that it contains only characters, digits, and underscore. So it can contain percentage sign or asterisk or plus or dash and so on. The second rule is it can't start with a digit. So you can name your file starting beginning with a digit, but if you will import this in another file, you will get an error. So it can start with underscore or with a character. Okay, how these variables are stored in memory. You can find the address of your variables using this command id. So I will start the Python PyCharm. Now we're not using much command line anymore. So I hope uh, you feel good with PyCharm now. So, or another environment, that's fine. So I will create a new project. And I actually set up, I believe it won't create a new environment. You remember we talked last in labs, we don't want to create a new environment. So if your project for somehow you can figure out how to create a Nepsin project on your machine, just you can go to Cedric right away. I mean, you feel free to walk during class and ask for help. Okay, so Week 2. And by default, it creates a starting file. So for now, I will comment this content, but in the end of class, I will explain how to use how to call file from another file, and then I will explain what does this if name equals main mean. Okay, I will use terminal for now. So let's say I create, oh, I should call Python. Let's say I create a variable a equals 2, and I can type print the, oops, the address in our machine memory. I can create b equals 2. Who knows if it will be the same address or different one? Cedric, no. Okay. You can see it's the same address. So if I create a large number and the same number and print addresses of these numbers, ID A, ID of B, you will see that now these addresses are different. Who knows why it's the same for small numbers and it's different for large numbers? Yes?
Caches the smaller numbers to save memory.
Yeah, I don't remember up to 100 something or 200 something. It allocates the memory for first 100 something digits, so they always have the same address in the memory. But it's not a good idea to allocate the memory for every digit. So for larger digits, it creates a new. Yep.
Beyond files. Sorry, you ran into them files on the line of work. like off screen. Is formatting and fire. So it's on.
Oh, sorry, what?
I didn't really think about that. Yeah.
Sorry, what I have, oh, maybe just because I have to, just because I had like two screens open up the two PyCharm projects. Okay. So if I assign variable b value of variable a, what do you expect to see for the address of b? Will it be like previous address of b, or it will be address of a if I assign a value to b? You can see now b has points on this to the same memory cell as a, which makes sense because we assigned value a to variable b. Now let's talk about types. If I want to see the type of my variable, I can just type. uh, and here it says that my variable a has type integer. If I want to see the type of a function, for example, type of a function print, for example, print because my function print doesn't return the value, it just prints, the type is called none. So the first class of types in Python, oh, and also, yeah, if you look at the type of the turtle, imported turtle, you will see that the type is module, and you can also look at the type of the function type, it will be a type. And as you can see, everything in Python is called class. So everything in Python actually is an object. Every variable, module, function, everything is a module. And the first class of types is called strange types. And this class contains only one representative. So this one representative is none. It means that it doesn't have a specific type at all. For example, if you have a function like turtle draws something, it doesn't have the return statement, so it doesn't return anything. But it will return something, so it will return none. Um, I don't know why it's here. I compare none and two, but they're not equal, so the result is false. So next class of types in Python contains two representatives. The first contained one, next two. So logical type contains only true or false values. For example, we compare two smaller than 7. It's true, so the result of this comparison is true. But this logical class, it also behaves as a digits. And true corresponds to 1. So if you type 2 plus true, it will return 3. If you type 2 plus false, it will return 2. With Boolean variables, we can do these operations. Negation, like not of false will be true, and logical or and exclusive or XOR, which means that the expression will be true if only of one of the statements is true. So these operations are lazy. It means that if you compare two expressions, for example, or, it will be true if just only one of the expressions is true. Do you remember logical operations? So in this case, my first expression is true. So the entire expression should be true. And interpreter doesn't go to the second expression. So you don't see the print after calling this line. If I switch these terms, first it goes to print, and you remember the function print returns value none, and none will see on the next slide is called false value. So it's interpreter understands none as false. So because the first it executes the first expression, so it prints none. Then, because it was false, it goes to the second expression. And the second expression is true, it means that the entire expression with or will be true. So next class is numerical numbers. And here we have, we can say unlimited number of representatives, because in Python, it's, I believe, unique language, which allows integers of arbitrary length. And what does it mean? It allocates, when you create a variable, it allocates a memory, but then if you, for example, take like 100th power of this number, it will add memory to this variable. And it's limited only by the memory of your machine. So yeah, you can think about this like unlimited length of the integers. Then we have floats. And for floats, we have a fixed length of memory. So if you are familiar with other languages, they have type double, double 16, double 32, double 64, which means they allocate 64 bits of memory for one variable. And this is what means float in Python. So for example, if you create two variables and add more decimals, like here, and compare these variables, we see that these are different numbers, but Python will say that they're equal. Just because when we add extra digits here, they don't fit in the allocated memory. So be prepared when you compare two different numbers, but it says that they're the same. So it could be over what is called over 1 Oh, what? Overflow. Yes, thank you. Um, with numbers, we have operations like division, and division changes the type. So if you divide two integers, you will get a float. We have also integer division or floor division and remainder of the division. For example, 7 divided by 3, we can represent as 7 as 3 times 2 plus 1. So 2 will be the result of the floor division, and 1 will be the remainder. Now, question to you. What if we divide -7? So 7 integer or floor, because it rounds up to the lower integer, floor division returns 2. Remainder returns 1, because 7 can be represented as 3 times 2 plus 1. If I want to compare, I use double equals. What if we um, want to find the floor division of -7 by 3? What are your guesses? So what if we what if we want to find the remainder? Maybe you can guess. Yep. So because we represent -7 as 3 times something plus remainder. And remainder is non-negative. So we use, and actually it's floor. So we round up to the previous integer. So because -7 divided by 3 is -2 something, the previous integer is -3. So we can represent this as -3 plus 2. So -9 plus 2 will give us -7. Okay. So it's not just the same as 7 floor division 2 and negative sign. And we have these operations with numbers. Comparison is double equality, not equal, less than or equal, and so on. Next type, or upper last type for today, is the strings. In this category, we have two subclasses: normal strings or Unicode strings, and binary, not binary, sorry, byte strings. So for byte strings, oh, I should, there is a type, there should be a byte with byte. Um, for normal strings, we just use quotes. For binary string, we use prefix B. What does it mean? Um, who knows what is the ASCII table? So, what does it mean bit? What does it mean? One I don't know. Can you see if I write here or maybe not? Um, I can use annotate here. What does it mean 1 bit? You can speak out, don't raise your hands. How much information can we represent with 1 bit? How many characters can be called? Yeah, you can just speak. 0. Just it's okay. So the bit is the smallest unit of information, and it can take two values, true or false, 0, 1. So how many characters can we encode? So 0 or 1 encode with 1 bit. So you, your guess is correct. Um, on the physical level, it means there is charge or no, there is no charge. So if I add one more bit, how many characters? So it can take values 0 or 1. How many characters can we encode with 2 bits? Or can you see if we use 0 in the second bit, in the first bit we can write 0 or 1, so we have two combinations. If we use 1 on the second bit, again on the first bit we can use 0 or 1 plus two combinations, so it will be 2 times 2 or 4. If we add extra bit, how many symbols can we encode? 8. And what do you see the general pattern? So if we have, for example, um, you remember float 64, so it means that we allocate 64 bits for one variable. How many different words or characters can we encode with 64 bits? Okay, maybe we can continue. So what happens when we add one more bit to our previous 8 combinations? It's multiplied by 2. And what is the general formula? 4 is 2 power 2, 8 is 2 power 3. It's 2 power number of bits. So if we allocate 64 bits, then we can encode 2 power 64. It's a huge number symbols. So the string is the sentence on the normal language, and we want to represent this in the computer memory, and we should somehow encode this into zeros and ones. So the ASCII code, it was I believe one of the first coding systems, is using only 7 bits. So I will. So here is ASCII table for these symbols, and in these symbols you will see digits, characters, uppercase, lowercase. it has the correspondence of the digit, and digit can be represented in binary system. So if, as I said, ASCII table used 7 bits, how many different characters can we encode with ASCII table if it uses only 7 bits? 2 power 7. So how much is it? Yes, 128. If you look at the table, you will see that it contains exactly 128 lines because it begins with 0. So this is a limited number of characters. We can't encode other languages with this table, for example. So nowadays, this table was extended to Unicode table, and it contains more than 1,000, I don't remember how much symbols in this table. So it contains Chinese symbols, it contains other Western European characters, so and other different symbols like dominoes. So in Python, the default coding for strings is Unicode 8. It means that it allocates 8 bits for one character. And 1 bit, 8 bits is called byte. So we can say it allocates 1 byte for one character. So, for example, in this word, hello, how many bytes it will allocate in memory if we use UTF or Unicode 8 encoding? How many characters in the word hello? 5. One character will be encoded with 1 byte or 8 bits. So how many bytes we'll use for hello? 5 bytes. So if I want to use so this word hello will be represented with zeros and ones in machine code. And this is what is called byte string. If we want to read this back, we should use exactly the same encoding system. Because if I use another encoding system, let's see what happens. So I will create a string, my string. And I will create a byte string, hello. If I decode this string and don't indicate the encoding system, by default it's the same that was used for encoding. It's UTF-8, and you will get the string that we actually encoded. Let's use another encoding system, for example, Unicode 16, which allocates 2 bytes. 16 is 8 times 2 bytes for one character. And as you can see, we get an error, but it's not because it can't understand zeros and ones. It can read any string of zeros and ones. The problem here is because first we allocated 5 bytes, so 1 byte is equal to 8 bits. So for the word hello, we allocated for H 8 bits, for E 8 bits, for L, for the second L, and for O. So in total, we allocated 5 bytes. Now, my interpreter, not my Python, sorry. I don't read the bytes. Looks at these sequences of zeros and ones, and it sees that for one character, there is 2 with UTF-16, 2 bits, 2 bytes. So for decoding, it understands this chunk as one character now. Even though it was encoded like this was one character, but the coder will understand longer sequence as the code for one character. Then the second one, and then it doesn't have enough bits to read the third one character. That's why we have an error. It's not because it doesn't understand the string, it just doesn't have enough bits to read, to encode, because in this encoding system, Unicode 16, it uses 2 bytes for one character, and it doesn't see 2 bytes. So we can, there's parameter ignore. If we ignore, or another one, replace. So if it doesn't understand something, it can ignore this or replace by the question mark. I don't think you saw this, but because, bless you, because I'm from Russia and we have Cyrillic, and it's not the part of ASCII table. Sometimes I received emails, and instead of the text, I saw just question marks. So it means that my machine's encoding system was different from the sender machine encoder system, and it just replaced these symbols with question marks. So replace, and now it reads this string, and you can see that it didn't understand the last one, so there's question mark. And the first 2 in this extended Unicode table, maybe they represent a symbol with a very large index, which represents Chinese characters. So this is just example that if you use one encoding system, you should use exactly the same decoding system. Otherwise, you can get something like this, which is nonsense. Oh, by the way, there is also in Unicode table, every character has also not only the index, but it also has name. And you can call the character by its name. For example, in German, there is a letter which is called SZ, I believe, like better. And it has name Latin small letter sharp S. So let's try to call this symbol from our Unicode table. Latin small letter sharp S. And I didn't put the quote. So this is the character. In German, it doesn't have actually uppercase. Oh, I didn't mention the strings have some methods like uppercase, lowercase, strip, which will remove extra spaces, split, which will split your string into words. So if we use uppercase, we will get just double S. If we use uppercase for character A, we will just get uppercase A. If we apply then lowercase, we will get exactly the same number character. So if we do this for our German character, what do you think to see? What do you think you will see lower? You would expect to see the same character, but it's not. So this is just to be careful and you should understand how this Unicode table works. And because this character doesn't have the corresponding uppercase character in Unicode table, then this transform is not one-to-one. Okay, you can see here this \n. This is called escape sequence. So for example, if we use print, so these are symbols that you don't see when you print the string. For example, if I print \n, I think you know what it does. What does this \n do? Yeah, you can just.
That's the new line.
Yeah, so you can see like extra space here. It adds a new line. Then there is. Okay. There is another escape character, \t, and you can see it adds a tabulation. If you want to see this \ in your string, you can use prefix R, which stands for row strings. A row string will print everything which you have under the quotes. And by the way, the quotes can be just one singular or double quotes. It's not important for Python. For example, if you use double quotes inside of singular quotes, it will print these quotes. So we use different kind of quotes to distinguish between the string type quotes and the quotes that we want to print. Because if you just use the same quotes, I believe you will get an error. But if you want to see the quotes here, you should use escape sequence and then it will work. So please use whatever quotes you want, but it's a good idea to be consistent. So if you use single quotes in the entire file. It will be easier to read your text. If you use double quotes, use everywhere double quotes. And triple quotes. Do you remember when we used triple quotes? Yes.
For the counting at the beginning of a function of the program.
in the beginning, it will be a doc string. But what if we use it inside the program? So, for example, let's say. So if we use this inside the program, it allows you to split your string into many lines. So if we print text, you will see this text about split into lines, different lines. Okay, I think this is all about the strings, the last class. So let's clear all this writing. The last class of types is called collections. And as it follows from the name, you can put several objects in one object, in one collection. So we will talk about dictionaries on lecture 6. So we're not talking about dictionaries today, but we will mention lists, tuples or tuples, and sets. On the previous slide, you saw the example with list where we split our sentence into words. It created a collection of subwords or list of words. So to create list, you can use or list parentheses or just empty brackets. You can see that it's true. You can check, bless you, if one variable or an object is element of your list, you can access to the element in the list by index. You can change your element or in the list. So, for example, I want to change the list element with index 2, 0, 1, 2, into -1. So I just assign -1 to the element with index 2 of my list. And there is also weird operation. You can multiply a list and it will just repeat this list 10 times. The same with strings. You can use a string, then multiply by 10, and you will get a long string, but repeated 10 times. The second type is tuples or tuples. It's actually pretty the same as lists, but there is one exemption. You can't assign a new value to elements of this collection. So if I try to assign 4 to my first element, I will get an error. These types are called immutable. You can't change them. And the last type of collections is sets. So you can't create set as empty braces because it's reserved for dictionaries that I mentioned before. So to create empty set, you can just type set. So here I created the set of numbers, and some numbers go repeated. If I print this set out, you will see that it won't repeat the numbers. So the set is the collection of undistinguishable objects. It doesn't have indexing, so you can't access by index to elements of the sets. But you can check if something is element of your set or not in your set. So let's quickly summarize what we learned about types. Everything in Python is an object, and every object can be stored in the memory, and we should name this object, and the name of this object is called identifier. It can contain only digits or characters or underscore sign symbol, and it shouldn't begin with a digit. Data types have different classes. The first is just one type, none, then logical, true, false, then numerical, integers with unrestricted length, floats with allocated 64 bits. Complex numbers, we're not talking about complex numbers. The Python has also fractions. You can add fractions with different denominators. It will find common denominator, but we won't use that. Strings, byte strings and Unicode strings, and they can have different encoding system. In Python is by default UTF-8. Collections, two types of collections, mutable and immutable. I should add sets here. Mutable are lists and sets. Immutable are tuples or tuples and strings. Strings is not a collection, but you can get access to the characters, for example, in the string hello. If I type 0, I will get the first character. You can get also ASCII code. And when we're saying ASCII code, we actually mean Unicode table code. I believe the first 127 characters in Unicode table, they're the same as in ASCII table. It's just extension. So very often we say ASCII code, but it's actually the code of the extended table. So for example, for character H, I believe it's ORD. If you want to find the code or in this Unicode or ASCII table, you can use OR operation. If you want to get a character by code, there is char, CHR operation. So to get a character by the index. Okay, let's do a break, 10 minutes break, and we will continue. We have to talk about input outputs, conditionals, and use conditionals to draw customized faces, like if you want smile or if you want sorrow. So we'll go to the code. Yeah.
What are they?
They are, let's see. They're neutral because we can remove element. Let's say, the card assets or let's shapes. Because we don't have actually access to elements by index. There is no way to change the element.
So we stop here.
Okay, okay. So.
Yeah.
Literally available the tools were used for to install different types like
And it can be hard.
the name of the person, the date of birth, so the so yes, the info means that to change these objects, the variable which for the memory is also changed. I think this is I could change this. It will change it against variable. I mean, for immutable, it will create a new object. For example, when you
Have a little reminder up there for my sessions, just in case. It's right in your face now, so I mean, hopefully you guys show up.
let's see. That when you change and then you can release, then it doesn't create a new label. But if you want to change something in the tuple, then it will create a new variable. But since I think it won't create a new variable.
But we cannot change anything in the tuple.
Yes. Oh, I mean, for example, you want to add some tuple. Yeah, I mean, then you need to create a new variable. Then you can create a new variable. For example, your tuple plus another tuple, but it will be a new variable. But in sense, we can remove or join to set or add an element to the set. And we don't need to create a new variable. I think this is that's why it's because it's useful. Good question. Okay. Well, I need when I set up my everything was fine and I brushed it aside. I learned this is the oh, sorry, excuse me, so I don't remember. Did you come to install source on the or the navigable section? Section. Yeah, so if there is no okay, yeah, so what do I do for that then? Import.
Yeah, you import into it. So,
Or you have that.
oh, you just like. Sorry.
Oh, that I do it from here. Oh, yeah, you can try here also, just to double check. In-
So, I just like import.
Yeah.
But the good thing here, I tried.
That's
your
your
Yeah,
And,
activates it on this one, just have to take. So that's it. You want to. We can force it.
Okay, it looks important.
I'm happy to today. I'm going to the week, and so I have that.
Gotcha, okay.
So, have a. You'll have to, whenever you use that library, it's a quick logic, so whenever you use, if you want to. You wanna have that. Remember one. Because you can't really like turn it down, whatever, without having this. Icon.
Yeah, but it would be how well you reference it. Yeah, I said the problem, I said look at the Google. No, so, and when it installed the. It printers. Then, it's over that. It would be so maybe the folder.
That's really.
But. There was not. Yeah, now the second, another week. It was student first. Instructor. For 1 hour. On this.
I'm rewatching. No, I.
If you.
The way it works, isn't the thing, wasn't real. That's why. It's a Fushiguro dies like all the base. It's just how it works. When I get your projects. Yeah, that's split it into like, this is
He was gonna die.
He was gonna die if Mara killed him. That's it. However, two one killed him, so he's gonna kill.
By the way, so the slides are on my courses. They're not on the course page. Because each instructor creates, if he wants their own slide. Okay, let's talk about input and output in Python. So when you run the Python code, it will also create at the same time 3 files. One file for reading what you're typing in the command line. It's called standard input, std in. Another file, what it prints, it's called standard output. And the third file for errors. When you see errors, it will be stored in this file, std errors. But you don't need to work directly with these files. There is a command input that you can use. For example, I want to read a variable a. I can type input. And then I can type, for example, the value, and now my variable a will has this value. You also may include a prompt like something type here, and I add extra space. Then it will also print this prompt before waiting for your input. What is the type of the input? What do you think? What is the type of this variable a? You're right. So it's not an integer. It's because everything that we type is a string, the variable. If you want to have an integer, for example, if you want to, well, it's actually casted by default. I believe if you use a plus 3, it will work. Let's see. A plus 3. Oh no, it gives an error. So you should use the same data types when you add. So you could add here int comment. This will cast your string into integer. And then when you type 2, you will get the type of this variable integer. Okay, so this is about the input. Output, for output, we are using command print. And you can indicate the file where the output will be stored, but typically we just print the variable. And print function has two parameters that you may use. One is separator. By default, if you type different two, for example, variables, by default, separator will be space. Here, I want the separator to be a semicolon, and here's the result. And the other parameter, the ending of your line. By default, it's the new line. But for example, here I changed this to the semicolon. For example, you want to print several variables, and if they are printed all in new lines, it's hard to observe them. So you can use, for example, tab instead of new line here, or semicolon and space, and they will be printed just in one line. Yeah, you can see here, as a result, it doesn't go to the new line. There is also useful strings for formatted strings. Let's talk about this after conditionals. So conditional statements, there are two types. One is if-else statement, another is ternary operator. In if-else statement, we check one condition, and if it's satisfied, we execute the code under this condition, and we leave this statement. If it's not satisfied, like in this case, I want to check if my number x is divisible by 5, and 42 is not divisible. So it's not satisfied, it goes to check another condition. The syntax here is elif. For example, if it's divisible by 3, I will print it's a multiple of 3. And if this condition is not satisfied, you can check another condition, elif. And the last condition like if not any of the previous conditions were satisfied, you can use else statement. Pass means do nothing. It won't return an error, but also it won't do anything. So, formatted strings. They allow you to use the variables inside the string. So, for example, here it will print the x value and then the text. So I believe most of you would print something like that. Then plus, and then text. Because we use plus to concatenate two strings. But in this case, I will get an error because my a is integer. So what would you do? Maybe you would cast this into integer or into string, and then it will work. Or actually, I should use also space. But with formatted strings, we can do this much easier. With formatted string, you can just use f prefix here and pass variable as the parameter. So it's much easier syntax. And formatted strings can help you, for example, if a has many decimals, like 0 to the and if we want to print just two decimals, we can use the parameter here, which says 2 digits before the dot and 2 digits after the dot. So let's see, you can use formatted strings. It's much easier than just to concatenate strings. Now let's use this knowledge for this customized face. We will ask user which face they want to draw, smiling or sad, what's the radius of the eyes, and maybe we should check also in our code that the radius of the eyes is not larger than the radius of the head. So we will use if statements and inputs. And I will just copy paste the code from the course page. I don't want to write that. So here is fancy face, save as, and I will save it in our current project. I think I didn't click. I didn't click. Okay. Here is the file. Let's run it. So if you want to run the other file, by default, it runs this main file. You can change to the current file here. So you can see the code, for example, draw mouth. The draw mouth is a function, but now it will take also the argument. This argument or parameter of this function is the type of the mouth. Depending on this parameter, so if statements, we will draw like lines up or lines down. So if and if there is something else, then it will draw just a flat line. So these are test cases. Okay, here we'll read this variable mouse type. You can see input, then prompt, and then because we don't have a cast, it will read this as a string. I radius will be an integer, so we have a cast into integer. Okay, and they have also this check for eyes that they can be larger than a specific radius. So it would be weird that the eye is larger than the head. Okay, so let's type, for example, smile. Eye radius 5. And here is okay, and here is the face. I don't know why it didn't try. Maybe the smile. Let's execute this again. Hmm. It's not a smile. Oh, because I put quotes. Okay. It's confusing because they use quotes in the prompt and I use quotes, but I shouldn't use. Okay. Thank you. No. Okay. So I should just type smile without any quotes. Okay, here it is. Then we have test cases. We can run them, yes. Smile 15, smile 25, frown 5, frown 25, smile 35, and so on. Okay. So now, from this week, you're allowed to use the variables for your functions. For example, for the color, you remember the first lab, we didn't allow you to use colors as parameters of your functions block. So the second program is about drawing a tree, but also returning it's not the tree that you were working on. we will talk about recursion next time. Then we will be able to draw really fancy trees. But but this function should also return the length of all the trunks. We call these functions fruitful functions because they will return the value. But before, let's talk about the scopes of the functions. So in Python, there are built-in modules like turtle. You can import turtle, but there is also built-in like minimum. It will, if you type min of 2.5, 0.7, it will return 2 because 2 is the smallest number. But you can change this default functions or variables. For example, here I assign the value 42 to this min. And if I will print min after that, it will print 42. We call these global variables. Then I can create a function f and redefine this min inside this function. If I print min inside this function, it will print the value that was assigned inside the function. In this case, 2. In this function, I create another function. And in this other function, I redefine this min as 0. If I print, I will get value 0. But if I type here print min again, which value I will see if I will print after execution of the function print min, I will see 42 because this change takes place only inside the function. So we call these variables local because they take these values only inside the functions. If we have function inside function, then we call like higher level variables enclosing, and the variables outside the functions we call globals. So the idea is there's LEGB rule. It stands for local enclosing global built-in, that if we call inside the function a variable, first our interpreter looks for the variable inside the function. If there is no this line, it will go to the higher level and will search for the variable on the previous level. If there is no variable on the previous level, it will go to the global scope. If there is no variable in the global scope, it will search in the built-in functions. If there is no such name in built-in functions, it will return an error. So let's do one example, and after that we will go to the tree length evaluation. Let's create one function, f, without parameters. And I will assign a value 0 and print this value. If I call this function, what do you think this print will print? Yep.
So, 0.
So the first thing you should ask if it returns something or not.
Would return none.
None, yes. So because it doesn't have a return statement, it will by default return none. So we should see none somewhere. But because it has also print statement inside, it first will print, and then it will return the value of the function. Does it make sense? So, and by the way, you remember our a had value different than 0, but it was a global. Inside my function, I assigned a value 0, so it printed 0. Okay, so if I would create a function, let's say f return a and print it, then okay, I didn't write also a equals 0, but it's fine. So I just want to show that if a function has a statement return, it will return the value. If it doesn't have statement return, it will return none always. So if you want that your function returns none, just don't write return none, because it will return none without statement return anyways. Okay, go back to trees. Let's create a function that draws just a stem. So the parameter of my function will be the length of this stem, the height. So up, down, and we return the size, this parameter, which is the length of my tree, of my very small tree. If I want to create 2 branches, I will go up to this parameter size, then rotate by 45 degrees, and use this function which goes up and down. And we'll store the value, but I will use this function with twice smaller length because this branch is smaller. And because it has return statement, I will store the length of this branch in variable length. Then rotate 90 degrees, again call that function up down, and store the length. And then sum up all these lengths. This will be the length of all the lines on my image. Does it make sense? I don't want to run this code and don't want to write the code for tree of the level 3 or 4 because it's annoying. And next time we will talk about recursion where you can write this code just in few lines. In the remaining part of the class, I want to talk about the functions and the scopes of the functions. For example, how we grade your homeworks. We import your files. So let's talk about this. And that's it for today. So I will create 2 files. One file will be like the file that we submit, another file which reads this file, okay? I will call this file test. Oh, it should be Python file, sorry. So let's say you write your homework file. So you imports total, and you can import this with lsst, for example. And then you write your function, define my function. And in this function, you do something, for example, draw a circle of radius 30. If I run this code, it will work. But because I didn't call the function, it just didn't draw anything. Then in main file, I can call your test file. I can do import test and then run your function as test.my. So we do a little bit different. We import anything from your okay, before going to another way to do this, the first question. Can I read of this import turtle in your file and paste this in my file, in main file? Will it work or not? So we talked today about the scopes of the functions. Now I want to do the same with files. Why, if I call turtle like in my main file, maybe your local file will also see this. What do you think? Will it work or not? Error. So the files or modules in Python, they have only their own scope. They don't see imports from other modules. So if you want now about aliases. So what we do in our code, we do from your file import everything. If we do this, I can call just the function my, which was in your code. And I should uncomment here turtle, and this will work. But because we use import everything, it also will import TT, which is alias for your turtle. So I can use here, for example, TT, even though in my file I didn't call turtle. It should work. The possible problem is that if in our testing file we create a variable with the same name, TT, it will kill your turtle. So if we say, for example, TT equals 2, then TT done wouldn't make sense to my file, because for my file, TT means 2. Because we don't use these variables in our testing files, feel free to use aliases for turtle and fallbacks. So now, if you want to use like print statements in your code or run functions in your code, you can do this, but with one additional line: if name equals main. And here you can do, for example, print and it will print if you run your file. Hey, dude. But if we import your file in our file, it won't print this. So it just draws and it doesn't print anything that you have after this statement. So as you remember, every module has parameters. We can look at these parameters if we type dir test. So these are all the parameters of your test file. And this test file has a parameter name. The parameter name for your test file is just the name of your test file. The parameter name of the executing file is always main. So it printed the name of this module, but the name of my file is always main. So that's why it's when we check this line, if name equals main, it sees that the name of this file is actually test, not main. So it won't execute anything after this line. So feel free to now to submit your files without comments, with any code, but after this statement. So our file won't run anything after this statement. Now let's do the quiz, okay? Go to my courses and I will open the password. But in main file, sorry, I just forgot, I will say about the main file. In main file, when it created the default file, there also was this statement because it's the main running file. This statement will be true, so this code will be running in your file. But if you're using just one file, don't bother, just don't type anything. It's important when we work with several files.
We want to check the name of the file.
Sorry?
Why would you want to check the name of the file?
So if this name is different from main, like for example in your test file, oh, because we import in my file, I do import. I want to import only modules. I don't want import text. So that's why we put this after the statement if name includes. I don't want to import any prints, any drawings. Does that make sense? So I want to import only functions. Okay. Quizzes. Fruitful functions is the password. And I believe today it has unlimited attempts. So you should write this quiz on the full mark because it's unlimited.